This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series, session 123. Got a great presentation today. Happy meteorological winter. Before introducing our speakers, I'd like to begin today's session with some information about significant changes that are being implemented to the GOES-R series, beginning today with GOES 16 and on January 4th with GOES 18. I'd like to introduce Linda Gilbert, lead meteorologist at the Marquette Weather Forecast Office and our facilitator for today's session. Linda is going to walk us through these changes to the imagery. Linda, welcome back to the Satellite Book Club.
Thank you so much, Jordan, and good early afternoon, good morning to everyone here. So as Jordan mentioned, several changes are coming to the sectorized cloud and moisture imagery, or SCMI products on the Satellite Broadcast Network, or the SBN. These changes will go into effect today, December 1st at 18Z, so less than an hour away actually, for GOES East / GOES 16, and January 4th, 2023 for GOES West / GOES 18. For both GOES East and GOES West, imagery products denoted full disk will cover only the Northern Hemisphere. For band 13, which is the 10.3 micron clean window IR, full disk imagery will be provided at its full ground resolution of 2 kilometers. Full disk imagery for the other bands will remain at 6 kilometer resolution. This won't impact current AWIPS procedures, RGBs, or channel differences. On a more personal note, band 13 is crucial for monitoring weather systems outside of CONUS, such as Canada, for example, which is a huge benefit for offices like ours that watch the progression of systems ejecting out of Canada, impacting our land and marine areas of responsibility. For GOES East, imagery for the Puerto Rico regional sector will omit bands 11, 12, 14, and 16. For GOES West, when GOES 18 is declared operational on January 4th, imagery for the Hawaii regional sector will be omitted. The Hawaii sector is largely covered by the West CONUS sector, which is scanned twice as often. Band 13 imagery for a new American Samoa regional sector will become available. These changes will not be applied to GOES 17 before it is taken out of service. Both GOES East and West changes will revert temporarily for the month of February 2023, but will become permanent on March 6th, 2023. So what are the implications for AWIPS? Well, current AWIPS configurations will handle the modified full disk sectors and band 13 resolution changes, including RGBs and channel differences. No changes are required in AWIPS except the new American Samoa sector activating on January 4th. The Tower S team is working with Pacific Region to ensure they have the configurations to receive and display band 13 for the GOES West American Samoa sector. Obviously, today it should be going on as scheduled, like I said, in less than an hour. But for the January 4th impact, critical weather day, should that occur on January 4th, may affect the timing of these changes. And I believe, yep, I see that there. Lee has posted a link to the VLab article with more details. So I will pass that back over to Jordan.
All right, thank you so much, Linda. And as we'll mention at the end of this call, please feel free to reach out to our Tower S team if you have any further questions about this. And please keep an eye on your AWIPS. If there's any issues, we are standing by and willing to support you and your offices. All right, well, let's jump into today's presentation then. The title is the February 2 through 4, 2022 Ohio Valley Winter Storm, which was also known as Sleetfest. Our presenters, Brandon Peloquin, the Warning Coordination Meteorologist from the Forecast Office in Wilmington, Ohio, and Logan Clark, the meteorologist at the same office there in Wilmington as well. You just heard from Linda Gilbert, who will be facilitating our session today. And just a few reminders before we get started. As you heard at the beginning, this session is being recorded, so if any of your colleagues are off today and want to catch it later, they can certainly do so through the VLab. We will have an opportunity for Q&A after the presentation. We particularly encourage questions from our field offices and regional headquarter participants. Please post your question in the chat, and we will address them in the order they're asked. If you have signed in with your office account or without using your full name, please specify your full name when asking a question in the chat so we can follow up if necessary. We've also heard that some of the TowerS communications have ended up in the NOAA spam folders. Please check your NOAA spam folder if you are looking for more information from TowerS. We're always looking for future presenters, so if you would like to participate in the Satellite Book Club as a presenter or facilitator, please reach out to our team. We'd love to have you. We realize that AMS annual meeting's coming up. If you want to give that presentation second life as part of the Satellite Book Club, we'd love to have you. And just a reminder that we are not necessarily looking for just purely satellite topics. If you have a presentation that involves but is not solely related to satellite, we'd still like to incorporate it as part of this book club. And if you're looking for training materials on satellite data, the training team can help create materials that may be unavailable. Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank our TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, the GOZAR and JPSS program for their help with the Satellite Book Club. Thanks to all of you and our presenter and facilitator as well. All right, so let me just formally introduce Brandon and Logan. Brandon Peloquin, as I mentioned, is the WCM in Wilmington. He's been with the National Weather Service for nearly 20 years and the WCM in Wilmington since February of 2015. Logan has been a meteorologist in Wilmington since May of 2020, was a graduate from Ohio University and starting his NWS career just weeks after graduation. So we're glad that worked out. Brandon and Logan, welcome to the Satellite Book Club.
Thank you guys so much for having us, and thank you for joining us on this afternoon. We're definitely excited about the opportunity to share with you guys one of the more unique winter weather storms that hit the Ohio Valley just earlier this year, and what better way to do it on the first day of meteorological winter. So this storm was expected to be impactful enough that it provided a pretty unique opportunity to help us enhance decision support services between our local office and the Ohio Emergency Management Agency. So let's first start by talking about the synoptic setup that allowed for this unique winter weather event to occur. So here, the Wilmington, Ohio, or county warning area was just located upstream of a mid and upper level trough as depicted by the 300 and 500 millibar charts at the top of your screen there. And you can see as it's looping through, it's just carving its way through the central plains and eventually making its way towards the Midwest. Several waves of low pressure developed in this troughing feature with a well-defined cold front at the surface stretching from the northeastern US all the way into the Gulf of Mexico. As you can see from these looped images, the mid-level troughing feature was pretty slow in its eastward propagation, keeping that surface cold front draped across our forecast area for 3 whole calendar days. With low and mid-level moisture being advected in from the Gulf, this constant source of moisture, combined with a very slow-moving frontal boundary, provided the synoptic setup where we could see several rounds of precipitation through that 3-day period. Thermal fields from this synoptic setup also enabled precipitation to primarily fall as snow just northwest of that cold front, sleet near and along the cold front, freezing rain just southeast of the front, and then finally back to rain further southeast as those hydrometeors fell through a larger column of above freezing air.
Okay, thanks Logan, that was a great overview. What we're looking at on this slide here, it's a graphic of winter headlines that were in effect on February the 1st. Now this is at least 36 to 48 hours before the onset of wintry precipitation. Much of the area is already under a winter storm watch. That's the blue color you see here on the graphic for heavy snow or the expectation of significant ice. With parts of northern Ohio already under a winter storm warning, that's the pink color on the graphic here, due to high confidence in heavy snow. On the next slide here, we're looking at within 24 hours of the winter event. And the winter storm warnings in the pink color have been expanded geographically across most of Ohio and also adjacent states. And in fact, even though this is out of our area of responsibility, ice storm warnings, represented by the purple color, were issued for parts of central Kentucky where freezing rain was expected to be the main precipitation type. So confidence was pretty high in a high impact winter storm across the Ohio Valley. And because of this, this prompted frequent weather briefings from our core partners, including and in particular those in the emergency management community. In our briefing slides, we really wanted to communicate the impact this winter storm was expected to have. And one graphic we produced, called the slider bar graphic that you're seeing on this slide here, highlighted the high impact that snow and ice was expected to have across the state of Ohio and within our area of responsibility, which includes parts of Southeast Indiana and Northern Kentucky as well. And our partners have stressed the need to message impact in our briefings, and we've received positive impact from a graphic like this one on your screen. So through partner meetings, integrated warning team workshops, and other activities, we've also been told that time of arrival of wintry precipitation is critical for the planning and decisions that our core partners need to make. Maybe even more important than the forecast snow totals themselves. So in our briefings and also social media graphics that can be seen by the general public, we use timing graphics to show the expected transition of winter precipitation types from northwest to southeast, both early on when we still had uncertainty with the timing, and also later on when timing was much more certain, as we see with this particular graphic. And given how much we were messaging this winter storm, really communicating the high impact element of this winter storm, we received a new unique request from the Ohio Emergency Management Agency. So just to give you a little background, NWS Wilmington, Ohio, we serve as the state liaison office for the entire state of Ohio. And this responsibility includes briefing and supporting Ohio EMA during hazardous weather events and other state EMA needs. And the Ohio EMA Watch Office, which operates 24/7 and is an extension of Ohio EMA's EOC, or Emergency Operations Center, they first made verbal contact with us at Wilmington at about 10 a.m. on that Monday. That was January the 31st. Due to the complexity and high impact from the storm, we agreed that regular contact beyond the scheduled web briefings and conference calls would be useful and maybe even necessary. And we considered an on-site deployment from NWS Wilmington. However, Ohio EMA is in Columbus, which is about 50 miles away from Wilmington. This, considered with the fact that the roads could be pretty bad because of the expected snow, sleet, and freezing rain, we opted not to go down the road of an on-site deployment. Therefore, opening up a virtual platform with an open line only for NWS Wilmington and Ohio EMA was considered to be the next best option. And essentially what this would do is allow for dedicated 24/7 remote weather support that would simulate the level of support an on-site presence or on-site deployment would provide. And the NWS Wilmington staffing plan included one dedicated person to serve state needs starting January 31st and going all the way through February 4th. And this task was accomplished by both forecasters working in the office, and we also took advantage of the fact that some of our forecasters were on telework, and in the telework environment, they were able to provide that open line support as well. So through the winter event, frequent chat messages and links to graphics were exchanged on the Microsoft Teams chat room platform, including proactive updates of forecast changes and challenges before the onset of precip, and then the precip type changeover, and also amounts of the different precipitation types during the event. In addition, microphones and cameras were occasionally used to provide on-the-spot briefings to the Ohio EMA Watch Office that would then pass the information up the chain, and ultimately this information, went up to the governor of Ohio and FEMA and others above the Ohio EMA Watch Office level. So the Ohio EMA Watch Office Chief, Mustafa Wardak, he gave a quote here on using Microsoft Teams for dedicated weather support. It's on your screen. He said the open line between NWS Wilmington Ohio EMA Watch provided an easy access and acted like an unfiltered means of communication for Ohio EMA Watch analysts to gather firsthand information regarding forecast models from the subject matter experts. This channel enabled Ohio EMA to better enhance the state EOC posture.
Yeah, so obviously communication absolutely critical in this whole event. Certainly a rapidly evolving and changing event as we were closely monitoring it days leading up to the actual winter storm. So as with any event, right, there always comes the challenges and uncertainty. So with this particular event, some of the challenges were not only driven by the longevity of this precipitation shield moving through, as you can see from this looped HREF image here. And of course, the forecast uncertainty of where that transition zone would align itself, because that would significantly alter precipitation totals of various types. But also with the fact that we live in a day and age of just information overload, right? I mean, the public has access to a lot of data that we as meteorologists analyze, deterministic model runs from some of the more well-known models, the GFS, NAM European, and various forecast applications too to look at. And for this particular event, some of those models would have significantly higher totals predicted compared to what we were forecasting or expecting. So on top of trying to correctly predict the forecast and get the proper messaging across, we also had to hit on the fact that frigid temperatures would settle in behind this system, behind the cold front once it moved through, with an Arctic high pressure system building in. So this kind of led to some additional enhanced messaging about the potential impacts of the system, and the fact that with cold temperatures building in, it would be pretty detrimental to locations where additional power loss could be or would be anticipated, which again would presumably be where the freezing rain axis aligned itself for a more prolonged period. So because of that, that eventually led us into a change in our weather headlines, in which we now, based on the signal that we are seeing in high resolution model trends, as well as some real-time observations, the afternoon of February 3rd, we were finally able to make that upgrade from a winter storm warning to an ice storm warning for some of our counties in northern Kentucky and the lower Scioto Valley there in southern Ohio. So these were the counties in which over a quarter of an inch of ice would be favored. And like I said, with the threat of bitterly cold temperatures settling in the next day, we just felt that the upgrade to an ice storm warning would help enhance with the messaging for impacts of freezing rain on infrastructure that could be detrimental to public safety. So on that first slide, you probably remembered the name of this event. Our office nicknamed it Sleetfest, and we named it Sleetfest for a reason. So I wanted to show here, we did a couple of extra weather balloon launches at our office throughout this event, particularly on February 3rd, just to kind of monitor the evolution of thermal profiles in the atmosphere to kind of help us with nowcasting and evaluating the performance of some of those high resolution models and seeing how they were handling the storm. So one of the reasons the storm was nicknamed Sleetfest was due to the prolonged period of sleet observed for some locations around the I-71 corridor, including our local office. So we can see here the 12Z morning launch on February 3rd. This showed a thermal sounding that is favorable for sleet being the primary precipitation type, reaching the surface, given that large warm nose that you can see around 850 millibars, as well as a large enough sub-freezing layer near the surface to allow for that melted snow to completely refreeze into an ice pellet. So let's jump ahead 3 hours. Here's another observed sounding from a weather balloon launch that we did at 15Z. Precipitation type, can you guess it? It's sleet. Jump ahead 3 more hours. Now we're looking at 18Z. Again, taking a look at the thermal sounding here. Really no major changes that you can see between the last couple of soundings. So the precipitation type that we're seeing at the surface, once again, sleet. Now let's jump ahead 6 more hours to our synoptic sounding at 0Z. Precipitation type that's being observed at the surface, well, it's still sleet. Although at this point, we are noticing that the warm nose is far less pronounced there at 850 millibars, and thus would lead to eventually a transition to snow or primarily snowfall at our office very soon. But certainly a very unique setup to where we could have this, again, this prolonged period where our thermal sounding just was favorable enough to allow for sleet to fall for a very prolonged period at our office and some other locations, like I mentioned, around the I-71 corridor. So what was the result of this event? Well, this winter storm materialized with a very sharp cutoff in snow totals across our county warning area and really the entire state of Ohio in general, with the I-71 corridor roughly marking this transition zone. Anywhere from about 5 to 10 inches of snow accumulated, you can see there just northwest of I-71, and a gradual decrease in those snow totals as we traveled southeastward. And some of the reason those totals were severely undercut was, of course, due to the sleet. So sleet totals were highest just along and southeast of I-71, including our office. Some locations observed 2 to 3 inches of just pure sleet accumulation, including our local office. So portions of southern Ohio, of course, you have an area with very prolonged sleet. You also have an area with very prolonged freezing rain. So portions of southern Ohio felt the greatest impacts from freezing rain, with several reports over a quarter of an inch of flat ice accumulation measured. And in fact, you can see here that nearly 7% of residents in Hocking County, Ohio, were without power, which is that dark red there in the state of Ohio, showing the power outages. And again, that power outage was primarily due to freezing rain accumulations. And if you kind of recall where we did put out the ice storm warning, it roughly does match up pretty well with those counties where you see increased power outages. And of course, the impacts continue to be felt days after the event as bitterly cold temperatures moved in behind the cold front with Arctic high pressure building in. So since this event, this big winter storm, Ohio EMA, they have requested actually dedicated remote weather support several additional times, including June and July just of this year, but this time for severe weather events that impacted the state of Ohio. So NWS Wilmington and Ohio EMA plan to continue to evolve this type of dedicated remote weather support, and this evolution will include devising minimum hazardous weather triggers in order to better plan in advance the need for this type of weather support. NWS Wilmington may also look into developing a dedicated workspace within our office to best focus on core partner communication, which is something we are looking forward to continuing to evolve as we move forward. So that's all we have to share with this presentation. So we appreciate you guys listening and look forward to any questions that you might have. So thank you so much.
All right, great. Thank you so much for the excellent presentation. I would like to encourage everybody to please remain on the line here. Join us for some additional discussion. If you've got any questions, please feel free to submit them into the chat box and we will go through them, or any other comments or feedback would be appreciated. If you are specifically from a field office or regional office, please make sure that you put in your full name in the chat when you are asking a question or providing feedback, as mentioned at the beginning, just to make sure that should there be additional follow-up necessary, that able to contact you after the conclusion of today's discussion. And it looks like there the Satellite Book Club survey has already been linked in there. So please do go ahead and fill out that feedback survey that is posted in the chat room. And yeah, they would love to hear from you on how you think all of this is going. All right, so in a week from today, on Thursday, December 8th at 1 p.m. Eastern time. So did want to make note that for next week, there is a different time, just for next week only, 1 p.m. Eastern time. Kyle Perez, a meteorologist from the Springfield, Missouri WFO, will discuss leveraging remote mesoanalysis in NWS Central Region during the December 10th through 11th, 2021 tornado event. Also want to encourage everybody here attending today, or if you are listening in from the recording portion of it, please contact the TowerS team, Lee Byerly and Kashad Bowman, for any questions about the SBC or for configuration of satellite products. They will definitely be able to help you with any questions that you might have on that. All right, so at this point in time, it looks like we've already got a chat from someone in here. It says, just for your information, archived Sierra advected layered PW loops showed the big picture moisture as well, and he's got several links in there. The Sierra advected layered precipitable water product shows the precipitable water at 4 distinct layers of the atmosphere and will be an operational satellite moisture product on NWS AWIPS workstations later in 2023. On these loops, notice the long fetch of moisture from the Gulf of Mexico in low layers, top loops, and from Mexico and tropical East Pacific at higher layers, bottom loops. So just an additional satellite product to look at before and during these types of storms. So thank you so much for that feedback there, Sheldon. And yeah, any other comments or remarks on that there, presenters? And then we'll go on to some additional questions. All right, not hearing anything from Brandon and Logan. Just want to do a mic check. Are you still online here with us?
We are still online and we are open to any questions that anyone might have.
All right, well then I'll just move on to the next question here. So this is from Jeffrey. I wonder how new CAPS handled the thermal profile. Is there archived data back that far?
Well, that's a good question. Not sure exactly how that handled the thermal profile, but I think the thermal profile was one of our challenges, throughout this event. I mean, even within the 24 hours of the first precipitation falling, I think there were a lot of differences among the guidance we were looking at as to what would fall where. And that's part of the reason why we did the special soundings that we did, to try and have some more real-time data moving into the event to give us a better handle as to where the rain to sleet, freezing rain transition was actually going to be.
And to just kind of build on that, as I was working through the event, out of all the models, of course, the North American model, the NAM, actually seemed to be one of the better models in terms of representing the thermal fields compared to others. And then it seemed like the HER was one of the better models too, that was, at least in terms of the evolution or the timing of precipitation, the transition seemed to capture it the best. So kind of between those two. And then of course using a number of other different tools and helping forecast. But that was something kind of unique about this event too, that I definitely noticed as we were forecasting it.
All right, great. Okay, got the next question here from Scott. Wasn't there a new CAPS related presentation on the storm in a previous SBC? That question might be directed toward the Tower S folks. Oh, and it looks like he answered his own question. Thank you, Scott, for posting that link in there. All right, so here's a question that was provided here previously. What feedback did you receive from partners, including the Ohio EMA, regarding the weather support or IDSS you provided them? We heard about that one quote in your presentation, but did you receive any additional feedback from partners?
We did. We received a lot of positive feedback from partners, certainly emergency managers that were at the local or the county level provided us positive feedback with the briefings we were provided, and then the frequent updates to the briefings that we provided them as well. And we were doing some local conference calls too, and we were outlining a lot of the same things that we were communicating to Ohio EMA with that open line. The big thing with Ohio EMA, it was that open line where they could reach out to us at any point in time. It was in between the scheduled 1 p.m. conference call or some back and forth on the NWS chat platform. We could just unmute our mics and just have a quick 5-minute conversation. And they really, really appreciated that. And I think it helped them do what they needed to do.
That's great, and so glad to hear that. I personally had a follow-up question about the staffing. Do you have any remarks on how that might have affected things from a staffing level? Like, was there any additional staffing? Did you have any staffing challenges to provide the support? What did that look like from a staffing perspective?
We certainly had extra staffing leading up to the event, probably a few days leading up to the event, and then during the event itself. And we certainly had to make sure that we had an extra staff member that would be dedicated to Ohio EMA the majority of the time. Now, on the midnight shift, a person could probably do double duty and a couple of different things that would include monitoring the open line. But at least during the daytime and during the evening shift as well, pretty much needed an extra body to be that dedicated person to Ohio EMA. And every day during our daily weather briefings that our office has every morning, and some impromptu internal staff briefings that we had some of the days in the afternoon as well, we talked about the staffing plan so we could make sure we had all the people we needed to do all the jobs that needed to be done during the event.
Okay, gotcha. Thank you. All right, definitely keep the questions coming and the discussion going. We've got plenty of time left here. But there looks like there is another question here. How did the weather support, or IDSS, you provided the Ohio EMA differ from previous years?
That's a wonderful question. And in short, it was the first time that we had had this open line before. It was the first time we tried this. In the past, it might be a simple phone call. They're calling us, do a quick briefing. Maybe they're calling us a half an hour later or an hour later. And we just thought, in the absence of an on-site deployment where we're there and they can just, we're in the same room, we're in the EOC together, we can't be there for a deployment. So why not simulate that with this open line? So they didn't need to keep calling us on the phone every half hour or whatever it was for any updates. We could just talk to each other almost like we were there. And a benefit of the open line is that we could share graphics. We could share some of the things that we were seeing and that were going into our decision-making process for the forecast itself. And they really appreciated that. So I think a big difference is the fact it was the first time and it was successful. And that's why it's happened a few times since then for high impact weather events. We don't want to do it for every winter weather advisory or every slight risk from the Storm Prediction Center, but the high end events, the big winter storms, the maybe moderate and higher risk for severe weather, or moderate to major flood events. This is something we would probably do in the future as well.
Sure, gotcha. All right, sounds good. All right. We've got Jordan has a question. Jordan, can you unmute yourself?
Sure, thank you, and thanks so much for this presentation. So, as I introduced myself, I work in the Office of Observations here at headquarters. It's important for us in headquarters to understand how the field is using the different types of observational data, and precipitation type, as you talked about in your presentation, is often a tough one. You showed the balloon launches that were done to help with that. And I believe you said you did extra balloon launches as well. What other types of data could have been useful? Was there a use of aircraft data? Would additional satellite products have been helpful? A mesonet? I don't know. If you had a wish list to improve the observational data for this event, for other similar events, what would you have included?
Yeah, that's certainly a great question, and it's always a challenge with mixed precipitation, and your entire county warning area is pretty much seeing anything from rain to snow and everything in between. Yeah, I think one of the things we actually we looked at a lot was actually correlation coefficient in with our WSR 88D. That was actually pretty beneficial in kind of highlighting where that rain snow line was. So that was something that we kind of had up on loop pretty much continuously throughout the event to kind of monitor the slow progression of that. certainly ASOS, AWAS, those ground observations to kind of give the ground truth of what was happening. We relied too a lot on MPing and just getting those reports from people to understand, how it was kind of evolving through their area. Because I think with this event, it definitely took longer than I think what most models were showing to progress through. We knew it would be kind of slow, and we'd have this prolonged period of all these different mixed precip types. But I think for some areas it lingered maybe even longer than we expected. So, I mean, yeah, if we had more ways, more observations, the balloon was great at our local office, but of course, you're just measuring kind of one single point, and you're not getting those thermal fields across your entire, county warning area. So more ways, I guess, of having a means to get those thermal fields, not just at the surface, but further aloft in different parts of the county warning area would have been certainly beneficial.
Thanks so much.
All right, we've got a question here from Joe, asks, were there any AWIPS things that worked well or not so well in the context of this live interaction mode of operation?
Well, with regard to our interaction with Ohio EMA specifically, I'm not sure we were using AWIPS a lot. I remember I did this from home a couple of days, so obviously I didn't have AWIPS at home, but I was in contact with the forecasters who were in AWIPS and looking at data and things like that. So I think the main theme was communication and collaboration, everybody talking to each other. I'm briefing Ohio EMA, but I need to make sure I'm in contact with the operational forecasters as well, so I know what they're looking at and what they're seeing. And so through our Google chat room, I was in contact with them. They were looking at things in AWIPS, but it wasn't necessarily a requirement for me as the DSS person dedicated to Ohio EMA to have access to all that information in AWIPS. But certainly, don't get me wrong, if I could have had AWIPS from home, I would have used it.
Perhaps AWIPS in the cloud will be something in our future, right?
There you go.
Yeah, I know.
All right, and our next question here comes from Jeffrey. Brandon and Logan, we used your open line. Oh, I'm sorry, this is not a question. That's some feedback here. We used your open line technique with Jackson WFO for the Kentucky flood event. Looks like this was Molly's idea. It was very helpful. Thanks.
Great to hear. Yeah, thank you for sharing.
All right, we still have just a few more minutes before we should be wrapping things up here. So I will give it maybe just another 30 to 45 seconds. If you do have any other questions, anybody here, discussion points, feedback, do put that in the chat. It looks like here we've got another remark from Sheldon. Another useful satellite product could be the NWS snowfall rate product, and maybe also the first half of February 4th, and got some links posted there in the chat room. So thank you, Sheldon. Additional feedback here from Juan, and I do apologize if I am missaying the name there. NWS has a satellite snowfall rate product and a radar satellite merged product. Images are projected on Google Maps and posted at near real time, and there is a link posted in chat. Might be something to look at in operations and be helpful. So thank you for that. Any responses or remarks there, Brandon or Logan, from what was shared?
Well, this is great information. I think this is information we can use in the future as well when we get winter storms and other hazardous weather events. But you know what, I think a point, look on your screen here, look on the right-hand side of that map summary that shows snow and ice totals. There's some pretty significant gaps there. I mean, look at, kind of southeast Ohio and south central Ohio where there's not as many circles. So, that's a challenge that we have, getting data. And, obviously there's, data from satellites and radar is important in the ASOSs and the AWASs, but you know, the spotters are important too, spotters and other observers to give us data there. So, you know, we're open to getting as much data as we can because it helps us in real time during the forecast. And then after the fact, when we go to see what actually happened, you know, having those numbers is so very important.
All right, great. Thank you for that. Okay, so at this point, it sounds like and looks like the discussion here is winding down. So I will go ahead and turn it back over to Jordan. Thank you all so very much. This has been great.
All right. Well, thank you so much, Linda, for moderating that discussion. And thanks so much, Brandon and Logan, for your presentation today. Really great to see and hear about how we're communicating the predictability challenges of precipitation type with our partners and informing our services. As Linda has mentioned, in a week from today, on Thursday, December 8th, the Satellite Book Club continues, but at a slightly changed time, just for next week, 1 p.m. Eastern time. We're going to have Kyle Perez, who's down as a meteorologist in Springfield, Missouri, and is going to discuss leveraging remote mesoanalysis in Weather Service Central Region during the December 2021 tornado event. You're also encouraged to contact the TowerS team, Lee Byerly, Kashad Bowman, for questions related to the Satellite Book Club or for the configuration of satellite products. As I mentioned, as Linda mentioned, with GOES 16 sectorized cloud moisture imagery today, some changes in your AWIPS. If you have issues, please reach out to the TowerS team. We're certainly willing to help with anything on that. All right, well, without any further remarks, we're going to go ahead and conclude for today. Hope you'll be able to join us next week for the presentation. Happy meteorological winter, stay well, and see you on another Satellite Book Club soon. Take care, everybody.